Continuing on that subject of haptics, our sense of touch, and how it ties in with the technology we use now and what we'll be using in the future. So far, we've taken these unique senses, pain, pressure, and temperature, and looked at them individually. But there's other aspects to consider: multimodal interfaces. Each channel of reception or feedback is what we can call a modality, whether this is visual feedback from your monitor or pressure input from your game controller. It's important that we understand that there's much interest in applying multiple modalities in order to enhance human-computer interaction. We are told that the goals of multimodal interfaces are both to create a more natural communication system, as well as to create a more robust system that introduces redundancy into a system. Adding a multitude of interaction methods, as well as displaying information in different ways, allows users to do exactly this. Found in an article in the magazine Communications of ACM from January 2004 out of volume 47. Here we're told what we should be made aware of while designing multimodal user interfaces. It's presented that any interface should be designed with the broadest range of users in context of use. Because if we're trying to create something that's more natural, it is essential that we as designers understand who might our users be, from cultural issues, the work environment, and if there might be any disabilities or other issues that impede a user's ability to interact. As a part of this, we also need to understand who's going to be using the system and where. The requirements for a multimodal display at a busy airport, it's going to be quite different than that of a personal mobile phone. Not only this, there's going to be different privacy and security issues to attend to, depending on what the device is being used for and the actual user themselves. We need to keep in mind of all this while focusing on the end goal of maximizing human cognitive and physical abilities. It's important to have many methods to input and display information. This doesn't actually mean that a user needs to be able to attend to all the presented information in order to comprehend what's being presented. This is because the multitude of information, the multiple outputs, are intended to help the user understand through redundancy. Not all users are going to use all the information that you provide. These guidelines that we're given, they tell us to integrate modalities in a way that we can fit the user's own preferences, as well as the context involved, also taking into account what the system functionally intends to do. As we begin to look at different ways to input multimodal information, it's necessary to find an appropriate output method that's going to match a user's input style. As systems are created to be used by a multitude of different users, it's important to make sure that the multimodal interface is adaptable to the needs of different users as well as the different context in which it will be used. Your smartphone is an excellent example of this. It's typically used by a multitude of different users around the whole world. Any technology in a mobile phone should be accessible and easy to use by the majority of these users. As much as we try to use multimodal interfaces to create a more natural interface, we have to keep consistency. Gestures, for example, should always execute the same or similar commands throughout an interface, from program to program across all applications. For example, making the search by voice, typing it in, or any other method that might exist should provide identical results. Consistency aids in reducing user frustration. As we look through this article, as a final guideline, error prevention and handling needs to be implemented some way in a multimodal system. How that's done, it's up to the developer of such a system. But considering that users will not always interact the same way with a system, there should be a way to ensure that the data entered is what the user wants to put in. Now keep in mind that the article that we've been looking at and the guidelines that it's given us are at times a bit vague. In part, that's because it's difficult to know what application or system is being designed for use with a multimodal interface. These guidelines help to keep certain aspects in mind when starting with or working with a project. Haptics. Let's talk a little bit about safety. We're going to take a look at the article Tangible Multimodal Interfaces for Safety Critical Applications by P. Cohen and D. McGee, which by the name of the article, of course, is on the topic of safety critical applications. These researchers took a look at some of the challenges facing integration of multimodal systems in what we can call safety critical applications, such as military and hospital use. As we digitize much information to make industries far more efficient, we have to note that safety critical industries have always relied on paper. If we take an objective look at paper itself, it's not only cheap, it's often available, lightweight, and it can be used for collaboration. It can be found in various sizes, and most importantly, paper seldom fails. It's not affected by network crashes, damages to a device, power outages, or even battery failure. When we are working in what can often be considered life-threatening situations, it's crucial that we have a fail-safe system in place. It's for this reason why multimodal systems have seen a lot of resistance from professionals. P. Cohen and D. McGee propose that rather than ask a user to change how they work, designers instead need to design systems around users' current methods of work. It's also important to note that the typical keyboard and mouse input does not translate well to mobile use or in collaborative environments. In the article we mentioned, the option that's looked at is known as a tangible multimodal system, or a system that allows users to use enhanced versions of tools and objects that are already in their workplace. For example, we can look at a system by the name of Rasa, which allows military personnel to continue to use paper maps in combination with post-it notes. A map, for example, is placed on a large digitizer that captures any inputs officers put into the system, as well as symbols placed with post-it notes. This information can then be broadcast to where it needs to be. Information from other collaborators' maps are projected over the existing map in order to integrate both data. The obvious advantage of using a paper map is that if for some reason the device itself fails or the network fails, the paper map stays where it is and it can be continued to be used by officers. When the system comes back online, it can then again broadcast the updated information. Yet another device we can look at is the Anoto pen. It's an ink pen that's used like any other pen would be, but it comes with the addition of a camera and a Bluetooth radio, allowing the user to digitize their pen strokes. This allows, for example, a physician to write critical information on a paper form and also have a digital copy that can be readily accessible anytime, anywhere. So as you can see, there's many different methods for exploring the future of multimodal technology and how we can expect them to integrate into different industries. As the authors in the article found out, users are looking for technology that not only enhances their existing work methods, but can also be integrated into these work methods. These are very important aspects to take into account. Safety-critical industries tend to resist the introduction of new systems until they have been proven to be reliable. We can say that multimodal technologies can be of great benefit to these industries if the right approach is taken when integrating the technology to the very specific needs involved. Haptics. Natural interaction. If you remember from our last video, we've found that multimodal systems tend to require a different approach than traditional keyboards and mouse inputs. If you recall, modalities can be inputs and outputs, such as a press of a button on your controller or the vibration feedback you feel from your phone. Multimodality then is the combination of these multiple modalities. Now we're going to look at the article, Multimodal Interfaces that Process What Comes Naturally. This article explains to us that typical multimodal communication has us speak, shift our eyes, and move our bodies, rather than use a keyboard or mouse. For mobile systems, such as your phone, reliance on a keyboard or mouse limits our ability to interact with that system. In this sense, we must take a different approach than what we might use for a standard GUI or graphical user interface. Sensors such as microphones and cameras help us augment voice and touch in such a system. It might be possible to use the additional senses and outputs in order to add touch and pressure to continually increase the bandwidth of touch in such a system in order to further augment such interactions. The writers S. Oviatt and P. Cohen believe that one of the most important reasons for developing multimodal interfaces is its ability to make devices far more accessible to a wider range of users. One theme that we keep on running into, that having a multimodal interface does not necessarily mean that every input is going to be used. Part of having that multimodal system, those multiple modalities, is to allow the user to pick different modalities while ignoring others if they so choose. You as a user might not want to use a speech command on your phone while you're sitting in a classroom lecture or you're riding the bus. For this reason, it's necessary to give users the ability to choose how they interact with a device. On the other hand, the advantage of having multiple modalities is that this information can be fused together in an effort to reduce errors in interpretation from the users. An additional advantage of having these multiple modalities is that it also reduces the stress put on individual modalities. Looking at it from a human perspective, switching modalities can reduce constant stress on one's vocal cords or hands. You don't always need to talk to your phone, and you don't always need to type on your phone. you as a user have the flexibility to choose how you want to interact with your technology. As one final note, the authors of this article tell us that as much as we use modalities that seem natural for humans, we must be aware of a user's wish for privacy. Just because it's normal to communicate through voice doesn't mean you always want to communicate by voice. Discrete communication should always be an option when designing a multimodal system. So with that, be aware that natural interaction is quite important to how a device is designed, but also be aware that the way that we communicate with our devices is not always, for example, the way that we normally communicate. Unification. We're looking at unification and what it means in the world of interactive technology. Michael Johnston and his team at the Center for Human-Computer Communication at the Oregon Graduate Institute looked at the advantages of using multimodal interfaces for map-based tasks way back in 1997. Although by today this technology is outdated, the methods of how the system worked as well as the research methodology stay relevant. These researchers set out to see how advantageous a multimodal interface could be over the use of a unimodal input. Now, to clarify these terms, multimodal and unimodal. Multimodal is multiple modalities, multiple ways of interacting with a system, whether it's typing, using your keyboard, talking, touching, all the things we take for granted in our phone today. The use of multimodal interfaces aims to increase what we call the bandwidth between humans and machines. The more ways we have to interact with a computer or any other form of technology, that's the increased bandwidth that we have. The two inputs that they used in this study were a speech interface and a touchscreen used in conjunction with a digital stylus. These researchers found that the use of multimodal interfaces resulted in faster and more accurate input when compared to either a unimodal speech or touch interface. This means that having access to both voice commands and touch works to your benefit. Think about the way that you use your phone and how for some tasks you might prefer to use only your touchscreen, and for others you might like to pop up that digital assistant and just spout commands. In their research, their focus was on a map-based task, and they wanted to highlight some of the advantages over unimodal interfaces, where if you were only to use speech to, for example, draw a green line between two set coordinates, it would take a lot more words and time, not only increasing the amount of effort, but also the chance of error. Instead, if a user were to pick 2 points on the map using touch and then ask the interface to draw a line or a route between the two, it allowed for quicker, more natural, accurate responses. This is a process that we call unification, where the consistency of two pieces of partial information are verified and combined into a single result. They found that gestures were useful in compensating for errors that might occur over speech recognition. An important advantage to multimodal interfaces is having access to the separate modalities, as there might be situations where you don't want to use speech. For example, in the library, where you'd rather ignore that added efficiency and stick only to your touch interface. In this way, we can see that adding further modalities allows users to have an adaptive interface that is more comfortable and more natural to use in a variety of situations. During the mentioned research, they found that recognition technologies are prone to error for various reasons. In the case of gesture recognition, not only do us humans have distinct or sloppy handwriting styles, but also some objects such as map routes do not have a defined shape that can actually define what it is. For this reason, it's important to implement some sort of error detection and correction. This might be in the form of a required simple and easy predetermined input, or asking the user to verify what they intended as their input. If you've ever, for example, used your phone doing a voice recognition task, there's good reason why it comes back, asks you to confirm what you've asked before going ahead and processing the task. If we go and look at another article, Multimodal Interfaces for Dynamic Interactive Maps, we can see that Oviatt had also looked at the advantages of multimodal interfaces for interactive maps later in 2004 and found that many of the same issues existed when trying to work with a unimodal interface, specifically with speech interaction. It was found that speech-only interaction increased errors and increased the completion time of tasks. In user studies, when users interacted with a multimodal interface, all these problems declined substantially. We can think of the use of multiple outputs and inputs as far more consistent at providing you the information you need. When you play a game, not only do you have visual clues, you have audio cues, in addition to what might be a vibrating controller. For your phone, you might have a distinct ringtone for a phone call, or another for a text message, accompanied by a unique vibration pattern. When two outputs are combined, you are more likely to be aware of it. But you also have the flexibility that if, for example, you enter a classroom or a library, you can shut off the modality of sound to only have that discrete output of vibration. To summarize, what is unification? It's taking multiple modalities, such as sound, touch, and visual input, and unifying them to help you, the user, not only have a more accurate ability to interact with your technology, but to also have choice. With that, we conclude our section on multimodal interfaces. If you're interested in learning more about interactive technology, feel free to look at my section on the senses of touch, on haptics, and on multimodal interfaces. Next up, we're going to be delving more into the actual applications and devices that take these concepts and use them in real-world applications. Things like prosthetic skin that feels, real-world haptic displays, augmented reality, flexible designs, smartwatches, a lot of the tech you might not even think about, but is designed to help you and the people around you use the technology that you enjoy so much. And if you do enjoy this type of content or any other content that I've made, just please share the videos. If you like the videos, make sure to hit that like button. And otherwise, no matter where you are in this world, do make sure that you have a good day, a good night, and a good morning. Bye-bye.